Good evening, everyone, and thank you all for joining us today. My name is Rashmita, and I am the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. Abhishek from the GitHub team is here to answer all your questions, so please feel free to ask anything. I would now like to welcome Arun Kumar, our speaker for today's session. Arun has over 17 years of experience and currently works as a senior service delivery engineer in the GitHub Expert Service team at GitHub Inc. But for now, I will hand over to Arun to begin the session. Let me bring him into the stream. Hey Arun, how are you doing today?
Hey Rashmita, thanks for hosting me and excited to be here.
Awesome. Let me bring up your screen.
Yeah,
There you go. Over to you.
yeah, thank you. Good morning, good afternoon, good evening to everybody joining from different time zones and regions. I'm Arun. I'm part of the GitHub Expert Services, and in the next 60 minutes, I'll be just taking a session on the GitHub Actions or how you can automate your workflow using leveraging the GitHub Actions. Having said that, I'll just keep going through the slides. There will be demos, everything. So let's check it. In the next 60 minutes, what we are going to do is first we'll be setting the introductions on what the GitHub Actions are, and also we'll be covering on the workflow syntax. So basically, if you have to start using actions, how you can do it, and the environments and secrets that are available within the actions that can be leveraged. And similarly, how best we can manage your workflow in action because you have created it and within your organization, how do you handle it? And how do you build actions, the various runners that are available, and followed by a quick CA/CD workflow because that is predominantly being used by everyone and everyone will be interested on that. And in between the sessions, also I'll be having a demo. I've got a vast list of topics to be covered within the 60 minutes, and feel free to drop your questions. I got Abhi as well as Dhruv from that same expert services team to answer your questions. And if there are anything, any questions to be answered in particular, then I'll be taking it towards the end if the time permits. Okay, so this is our agenda, and let me get it. So, introduction. As part of the introduction, what we are going to do is we'll be covering, basically, I'll be giving you a high level overview of the GitHub Actions and some of its main use cases that what we see with the enterprise customers as well as the remaining users. So basically, what are GitHub Actions, right? At a high level, it allows you to automate, customize, and execute your software development workflows. And it is stored as a code. What does that mean? Say, when I say stored as a code, basically you'll be able to version control it, share it with other developers within your team so that it can be reused for any easy collaboration. And as part of the actions, GitHub Actions, also you'll be having the live logs. So whenever the action gets executed, you'll be able to see the live logs. And also you'll be having a visualized workflow execution so that it will be helping the developer to understand what is happening around in the background, where it has failed, how it has succeeded, all those things. And to ease out, say something called as a matrix build is there because if you're what your workflow, because usually what will happen is in the industry, because people will be trying to deploy the application or test their applications once it is developed across multiple platforms, various versions of the software, everything. So that is where, so it will be helping you. The matrix build will be helping you to run tests across multiple combinations of the operating systems, platforms, and languages, all in the same workflow. And yeah, and you have two options. You have the option to vote user owned runners, which is the GitHub hosted runner. Recently, we introduced a special one called the large runner, so which I'll be covering in the subsequent slides. And if you don't want to use the GitHub hosted runner, because some of the enterprises, they don't want their data or whatever it is to go out of it. So that's where we'll be also giving the option to use your own self-hosted runner. When I say self-hosted runner, you'll be hosting your own runner mission and you can execute so that it will be lying well within your network. Uh, so if you look at it, this is the typical DevOps circle, starting with the planning phase, then followed by the okay, yeah, planning phase, and continuing with the code build, test, then deploy, followed by the operate and monitor part of it. So if you look at it, let's start with the plan phase. This is where you'll be triaging the issues with the project boards. Here, you can use the automation to create the labels and close the stale issues that are not active for, say, a specific number of period, time frame, or whatever it is. And also, you'll be able to add them to the project GitHub project boards. One of the examples I would like to mention, right, because we work with the customer day in and out, and what we have seen is, or rather, we help them in creating a simple interface where basically their customers can leave the feedback on their site, what is being exposed. And once the feedback form is submitted, automatically the issue will be created in the repository. And in turn, the developers can start working on it immediately. So you can use the GitHub Actions for it. And you have the code. As part of the code, you have the code review, auto merge, labeling, all those things are possible. Then building, during the build phase, the automation can again come into the picture when you're compiling or building your code, and also storing your artifacts, right? Just like I mentioned, using the matrix build, you can just bring in as part of your build phase so that you can test it across multiple combinations. And with respect to test, if you look at it, you can automate your test suits, right? Using the linters by using the CodeQL for finding the security vulnerability as part of the test. And similarly, automation can also be done and install the the packages as part of the workflow. Once the testing is done, we are comfortable, then the release phase comes in. In the release phase, steps that you'll be taking might include publishing a new release or uploading artifact. Anything can be automated. Whatever you're doing as part of the regular SDLC under the release cycle, you can take care of all those. And finally is the deploy part, where you can deploy your application into the environment. It can be your on-premise environment, or it can be on the cloud. Uh, we are cloud agnostic, so irrespective of whether it is AWS or Azure or Google Cloud, anything it can be. And yep, and finally the operate and monitor, that is not in scope as of today. By the time we are speaking, maybe the engineering team will also work on it. So that is what we are looking at. Having said that, let us get into the high level overview of what is action, because we have seen where all the actions is applicable. Let's take a deeper dive or a bit deep into the GitHub Actions, explain the components of it. So at a high level, if you look at it, there will be three components associated with the GitHub Actions. So one is the event. So what is an event? So basically the event is a specific activity that will be triggering the workflow, right? So it can be anything, a commit to a branch, a commit to, or a push into the branch, anything. So you'll be able to configure any GitHub event that can trigger it. And the second, once it is triggered, it is going to call the workflow. So when I say workflow, it can contain one or more jobs, and every job will be containing one or more steps. So basically, the step is nothing but an individual task that can execute the code. And even the steps, you'll be able to call a shell command directly or reference an action written in, say, for example, JavaScript. You can do anything within the script. And every job, right? If you look at it towards the right, so once, okay, we know what is to be executed. So the third part of the handshake will be the runner, where every job will be connected to a runner. So it can be, as I mentioned earlier, it can be on your own self-hosted runner, or it can be on the GitHub runner also. So basically, the runner is the environment where the entire job is executed, and each step in a job executes on the same runner. So every job will have its own runner, and all the steps under it will be executing on the same runner, allowing the actions, the jobs to share the data within each other, right? You can, as I mentioned, you can use either a self-hosted runner or a GitHub hosted runner. And the runner will be always listening out for jobs, for the available jobs, and it can execute only one job at a time and reports the progress, log what are the outcome of it, whether it is irrespective of whether it is a successful one or a failure one, and it will back the result to GitHub. So when we talk about GitHub Actions, it is usually reference to all the components and not limited to Actions component only. So what we will do as part of the workflow syntax now, because we have seen the overview of the actions, what are all the components involved, let's go a little bit deeper into it, explaining what is the workflow syntax. When I say that, so these are all the basic syntax. So always, if you look at it within your repository, always the YAML file. So it goes with the YAML file. Basically, the workflow files will be in the form of YAML. In case say you're used to the Travis CI or the Circle CI as part of your CI/CD, obviously you're used to the YAML files. The same is being used. And the YAML files, basically all this YAML files, irrespective of whether it is just one or more than one, these YAML files have to be kept under this folder definition that you're seeing. So within your repository, it will be under the .github/workflows and followed by the name of your YAML file. And if you look at it, basically it has got one trigger. So basically trigger is nothing but the event. So in this case, whenever a push happens at any branch, whether it's a main branch or a feature branch, wherever the push happens, automatically will get triggered. Here you'll be having the option to specify, okay, I don't want uh, the event to get triggered on all the branches. I want only specific. Yes, you can mention it and get it. And once you have defined the event, then you'll be mentioning, okay, if you look at it, it has got one job. And within uh, basically it will be you have the job which will be running on the GitHub hosted runner. So if you look at it, it will say it runs on Ubuntu latest. As part of the runner, I'll be covering a little bit more on what are all the runners available and what are all the operating system that we are supporting. So I'll get into that. And within steps, if you look at it, we have mentioned under the job, we have got a step, two steps, right? So one is with respect to using the default one of checkout, which will be able to check out your current repository. And you're using another one, right? Another step where it will be using calling a superlinter, which can be used against your test cases. And also, if you look at it, as I mentioned, secrets, which I'll be covering in the subsequent slides, just to note it. Also, we are just assigning to a variable which we are reading from a secret that we have created within our repository at a repository or at an organization level. So just we covered at a high level on what the events are. Now let us look at what are all the types of events that are available. So events can be classified highly at three types, right? So one is the webhook event, the second one is the scheduled events, and the manual events. When I say webhook events, so everyone, people who are using GitHub, they would have been used to the word webhooks, right? Basically, it is you would have integrated with your other tools via the webhook with your GitHub repository. So that is where it is. Basically, what the webhook does is it will be allowing you to listen for specific GitHub events. And whenever that event occurs, you can send the payload with the event details to some endpoint. Whatever is listening, it will be able to send it. And even GitHub Actions works in the same way. And here you will be able to define. In the last slide, if you look at it, we are looking at just the push operation. So in this case, we are just taking an example of whenever the issue is either closed or reopened, automatically it will be triggered. Remember, just since we have mentioned just a closed and reopened, it will just get triggered only on those. Whether it is you're creating a new one or deleting the existing one, it won't be triggered. And we currently GitHub supports 27 different webhook events that we can use to trigger the workflows, and we can do that. And to add one more point, yeah, in your workflow, you'll be able to define multiple events, and you can also filter on the specific types, as I mentioned, because right now we have mentioned the issues and types. It doesn't mean you can stop. Maybe you can just further filter it out on saying that okay, on say on the specific branch, the push operation of it also you can add it so that it will be working on the combination of it. Moving on to the second part of the scheduled events, as the name suggests, scheduled, you'll be able to execute the events more of a cron job. So basically, you have the cron syntax, which is being supported by the GitHub Actions YAML file. So if you look at the current slide, what I'm showing, you'll be able to see saying that I have set a cron job with this syntax, the cron syntax, which means that every Friday, this job will get executed at 6:30 UTC. So it will be getting into this and you can do it. If you're using a GitHub, because whatever I'm showing, it is for the GitHub hosted runner, right? And in case you're using a GitHub hosted runner, we can't guarantee the execution of the workflow at the exact time because there is it will be based completely on the availability of the runner vision because there can be some times where it will get into the queue, wait for a specific runner to pick it up. So in those cases, just there will be a little bit time lapse. Otherwise, always it will be running on it. And third part is the manual event. So under the manual event, you have the workflow dispatch and the repository dispatch. So what exactly is a workflow dispatch? So when you mention within your YAML file that it will be going with a workflow dispatch, so you will be able to trigger the workflow via the GUI. So when I open the GitHub repository and get into the Actions tab of it, then under the workflow, you'll be able to see the option to invoke it manually so that you can run it whenever you want. Otherwise, you can make use of the GitHub APIs that are available to invoke this, and even you can use the GitHub CLI for doing it. And as part of the workflow dispatch, also you can define the set of inputs that you want. Say something like a branch name, only on this, what is the branch that it has to be identified or triggered on, and other parameters. Say you want to capture a couple of input based on which it has to be run, then you can define it as input and you can take it forward. And this will be event or this workflow dispatch event will be used to trigger a specific workflow. And if you want to trigger multiple workflows manually, then maybe you make use of the repository dispatch. So when you make use of the repository dispatch, so you'll be able to invoke multiple workflows in the repository. Just like the workflow dispatch, you'll be able to use the GitHub API also, and you can do that. So these are all the various event types that are available, and depending on the need, right? Depending on the need of the project or the task that you want to execute, then you have to uh, select one of these events and then take it forward. Okay, and jumping on to the runners. So as I mentioned, runners are the main thing where creates the environment where you'll be executing your workflow job, everything. As I mentioned, you have two types of runners, GitHub hosted runner. So GitHub hosted runner is completely given by GitHub. And as part of the free tier, I think you'll be getting around 2000 minutes. And if you're an enterprise user, you are eligible for 50,000 minutes free tier per month and it gets reset. And the second option is the self-hosted runner. Say you want to host your own mission where you want the job to be executed. That is also possible. That's where you'll be going with it. And whenever, so choosing the type of runner, it's obviously given within your YAML file. So if you look at it, the highlighted area, always will be saying that runs on. So when I say Ubuntu latest, automatically it will be taking, okay, it will consider saying that, okay, it is a GitHub hosted runner and it will be on the Ubuntu platform it wants to take, and it will be spinning a Ubuntu mission for you to execute the job. Similarly, so on the runners, as I mentioned, you have further, it's classified because the GitHub hosted runner is the normal one. So it has the OS supporting the Ubuntu, Windows, and the Mac OS. And all the runners are ephemeral. So when I say ephemeral, basically you'll be having a fresh start. So whenever the runner is getting initiated, so it will be having a clean slate. And similarly, when it gets closed, when the job is completed and the runner is getting terminated, all the data that it had, everything will be wiped out. So every time we are going to have a new runner of it. And if you look at it, these are all the specs that are available when you when you're going with the GitHub hosted runner. So basically, it will be going with a 2-core CPU, and in case of a Mac OS, then it is a 3-core. Similarly, the RAM will be the 7 GB for Ubuntu and Windows, and for Mac, it will be a 14 GB. And a standard size of 14 GB SSD will be there in the disk space. And default, you'll be getting a couple of software installed like wget, GHCLI, so that you'll be able to make use of them directly within your step. And in case you want to have, say, for example, I want to have certain software as installed, say a node or something as part of my execution, that also you can define well within our actions when you're doing it. And yeah, so this is, and one of the things to remember is GitHub hosted runner, it doesn't support the static IPs because if it is an organization or an enterprise where they want to lock the IP, then it will be a hard one. That is where. So in that case, you have the option of either going with a self-hosted runner, or you can also choose the GitHub hosted large runner, which I'll be covering in the subsequent slide. And if you're on GitHub Enterprise Server, the on-prem instance, then the GitHub hosted runners are available, and you have to you have to go with the self-hosted runner for that at this moment. And as I mentioned, the GitHub hosted large runner. So how different it is from the regular runner? With respect to the operating system and being ephemeral, it is the same. We are not deviating anything. It is going to be the same. Here, the large runner, the difference will be on the CPU, the RAM, and the SSD disk space. because there will be certain tasks which involves a greater bandwidth and a big meat of the mission, right? The infra part should be heavy enough for it to do. That is where the large runners comes into the picture. And it is, you don't have get any free minutes with the large runners. It is more of a pay as you go model. And with large runners, the advantage what you'll be getting is you have the option to go with the static IP. Say you want to have static IPs, then you can do that, and you can start doing it. Yep, as I mentioned, so in case you're going with the on-prem server, you are on the on-prem GHES, then you don't have the option of larger runners also. You have to go with the self-hosted runner. And the last option of the runners is the self-hosted runner. So this, as the name says, self-hosted, the enterprise will be using, right? You'll be having your own mission, which you'll be allocating as a runner for this job, right? You'll be getting it added so that it can do. Here, the infra and the updates to the operating system or anything, a software, everything has to be handled by the enterprise. GitHub won't have any control on it, and even the OS, everything. And how we are doing it, because in the last two examples, if you look at it, we're saying, right, and just taking a step back. So if you look at it, the run zone, it was a normal runner from that is a GitHub hosted runner. We are just mentioning whether it is a Windows or Ubuntu or Mac. Whereas with the large group runners, we'll be mentioning a group, which I'll be covering in the subsequent slides when I do a deep dive into the, I'll be showing a demo at the time I'll be doing it. Here you'll be mentioning it. And with respect to the self-hosted runner, always it goes with the name self-hosted. So when I say within my YAML, when I say self-hosted, obviously it will be looking out for runners that are there connected, and it will be waiting for it to pick it up. And if you look at it, also I have some couple of labels, right? The Linux, ARM64, all those. So basically, these are all labels because any enterprise, they will not be just going with one runner. They'll be having series of runners, multiple runners. So, and they should be in a position to identify what is meant. So that is where the labeling will be coming into the picture for easy identification. So the minute, say, for example, they have 5 self-hosted runners and one is on Linux, say 2 on Linux, 2 on Mac, and 1 on Windows. And with the labels like this, you'll be able to exactly pinpoint which type of runner, because all the runners need not be of the same spec, hardware spec. You can have differences. So they based on the label, you'll be able to take and then do it. And taking into the action. So this is the complete if you look at the YAML file, right, as part of the final introduction. So this is what we covered in the previous slides, the earlier slides. So GitHub Actions are reusable units of code that can be referenced within a workflow. And basically, GitHub will be running them on natively on the Node.js. So you can write an action in JavaScript, anything that compiles to JavaScript or the TypeScript, it will be running on the GitHub hosted runner natively. And you'll be having the option to run any shell command, right? Directly in your workflow. Within the steps, you'll be able to do it. Just mention, as the name says, right here. If you look at it, run. It's just a shell command I'm giving. I'll be able to execute as much as you want. And there is something called as the local action. So in case you want to execute, which is there as part of your repository, then you can just point it, saying that okay, this is, say for example, I have a shell script which I want to execute. Then I can point to this and then take. And similarly, the last option is the Docker image. And say, if it is not supported, you want to have it. So that is where you'll be able to also take it from the container registry and then reference it and then start using it. So these are all the 3 ways in which you can be referenced. And not always. There is something called as a GitHub Marketplace, where it's more like just like how you have the Play Store and the App Store. Similarly, we have the GitHub Marketplace, where you'll be having set of open source actions across the multiple domains, not just restricted to actions, but for anything and everything you see in GitHub, you can see it. And as of today, there are approximately close to 20,000 actions, and still we are counting, which is available for users to consume it. There will be, because people say, I'm developing something which can be used by everyone, I can just come and post it here and it can be. And there will be too many, because if I look at 20,000 actions, once, because obviously people will be asking, okay, how do I take it? Because how do I know it? So one of the things what GitHub provides is the verified creators. right? So whenever you open any of the apps that is being hosted in the marketplace, you'll be able to see a blue tick mark next to the name of it. So which means that it has been verified by basically these creators are being verified by GitHub and you can use it. However, we always suggest the enterprises, okay, when you look at it, do your basic testing on before you start using it, because even for certain actions, though it is not verified, it can work well. So it's up to the enterprise or the users who are using it to go and test it manually, saying that, okay, it is safe, and then we advise you to use it. And these references, whatever you have it within the marketplace, it can be directly referenced within your workflow, and it can be integrated into your editor also, the GitHub editor, what you see. And to make much more life easier, because there are people, okay, who ask, okay, I don't want to write it from the scratch. I don't want to remember the syntax. So how do you do it? So that is where we have the starter workflows. So whenever you get inside the actions tab, which I'll be covering during the demo part, immediately you'll be able to see, because there are pre-configured for specific languages and framework, the workflows that are available. So if you look at the slide, say something like deploying a Node.js to a Azure web app, similarly for Ruby and Docker container, Node.js, Python, anything you call it, you name it, you get it, right? So that is where you'll be having, you can just use it. Once you click on the set up this workflow, it is going to give you the template. And once you have the base, then you can work on it and then do it. And to make it much more, because GitHub will obviously, whenever you are going to click on the recommend me, then obviously whenever you open the actions tab, it will be analyzing the code, because analyzing the code, it will be able to give you, okay, suggest the workflows based on the language and framework. And whatever I'm showing, because for the cloud, obviously you'll be having a vast list of starter workflows. And for the GHES, the on-prem servers, there are, compared to the cloud, it will be limited, but you get a good quantum of thing. And as I mentioned in the earlier one, the workflow logs. So whenever you execute an action and say the workflow gets executed, once you get inside the actions, you'll be able to see. So once it gets executed, irrespective of whether it has succeeded or failed, you'll be able to see on how to set up a job. So what are all the things that have got executed and what is there, you'll be able to see all those. You'll be able to download the logs to review it. And similarly, you can have the permalinks followed by the timestamps, all those, and visualization of the graph view in case, because say, for example, you have environments and you want to show it, then it is also available. Maybe if time permits, as part of the last demo, I'll be able to show that. Let's see that. Okay, having said that, let me get inside the demo part of it, which is going to be exciting, I assume. Let me open up my repository. Give me a minute. Yeah, hopefully, yeah, perfect. I think it is available, right? Yeah. So what we will do is, the moment you get inside your, say this is my organization I have, and I have got my repository under it. The moment you click on the actions tab of it, then as I mentioned earlier, you're going to have these are all the starter workflows that are available, as I mentioned earlier. And also I can just go with a simple configure workflow. When I click on it, it is going to have the bare minimal one of it with some push operation and a workflow dispatch. And also you have the search workflows. Say I don't want to scroll through everything. I can just put a node and then click on it. It is going to recommend me all the Node.js that are available as part of it. Yeah. So what we will do as part of this demo is, let's go with a simple workflow. Just you click on configure of it. You look at it. It has created a simple YAML file well within the folder structure of .github.workflow within your repository. And so if you look at it, these are all the operations. So what I have done is, or what the GitHub has recommended is, it's a push. So these are all the events that it has created. So on a push operation, as well as whenever a PR is raised, automatically on the main branch, so this workflow will get triggered. Apart from it, also you have the option of a workflow dispatch, saying that from the repository I'll be able to do. And once you look at it, say this is the job that we have given it and the name of it. The job name is called build. I have kept it, and run zone. As I mentioned, this is the place where you'll be mentioning what type of runner you're going to use it. So as the name says, Ubuntu latest, it is going to be on a GitHub hosted runner with the Ubuntu OS as it. And once you get into the steps, you can have multiple steps, as I said. So the first part of it is whenever I say users and actions checkout, this is it is the default one that is available as part of the actions, and it will be able to download the code, whatever is there in the repository. And in case you want to, as I mentioned earlier, you'll be able to just execute the shell command on the fly. So just use the name run and you'll be able to do it. And it is an example where it is just for a single line. In case you want to have a set of, say, 5-line program where you want to execute rather than having a separate file together, then just instead of putting a giving it, just put a pipe symbol and keep adding your echo or the shell scripts and it will get executed. What I will do is we will just save it, saying that say test.yaml. So what I'm going to do is I'm just going to create into the main branch of it. So usually we don't recommend to do directly in the main branch, but for the demonstration we do it. Otherwise, obviously we'll be asking you the best practice is to create a new branch and then you check it, raise a PR, merge it. That's how we do it. So I'm just committing the changes to it because we are going to push it. Okay. Let me get into the actions part of it. So if you look at it, basically what I have done is within the YAML as we saw, because there was a option, the events were configured to perform the push operation. Whenever a push operation happens on the main branch, automatically it will get done. So that is where it is. So if you see it, I have just got, so click on the actions tab and you'll be able to see the list of workflows that have run. And you will be able to see a status, whether it is success or failure with a tick, green tick or a red mark. And when you get inside the test.yaml, I'll be able to see what has happened. This is the log that is available. So it will be showing you what all the things that have got executed. In case you're using any GitHub secret as part of your YAML file, obviously you'll be using, though if you want to put, it won't be printing it. Basically, it will be masking them and it won't be printing any of the secrets. So this is where it is. And in case you want, you'll be able to show the timestamp of it and you can just download the log archive also, because this being a small one, you can just scroll it and do it. In case you want to have a bigger one, say the CI/CD where you want to implement, there is some error, you want to look at it or analyze it, that is where you can just download the log archive. It will be giving you the multiple stages how it is and you can do it. And you'll be also, in case of a failed job, you're making some changes, you can just click on the rerun job. Once you give the enable debug logging, so it will be helping you with the debugging also. It will be printing all the statements and it will be helpful. Okay, yep, this is the part of the demo. Anything else I'm missing? I think we are good with this. Yep, so this is the part where we'll be covering it. Having said that, let me move on to the next part of it. So the environment secrets and variables, because as part of the last slide, we have seen how you can, what is the benefit of using action and how you can use it. In case you want to create a workflow, how do you do it? So we explored that part of it. And just we'll be covering the environment secrets and variables as part of this. So basically, what is an environment? Environment, as the name says, it is the different environment you can create and for controlling the deployments. And on top of the environments, you can have the gated deployments with the approvals. Say, for example, you want to have multiple environments for testing, right? Say, starting with the development, QA, and then you want to push it to the prod. So before doing that, you want to test it in the environment, different environments. You can set up all those environments, and also as it is getting displayed in the slides, you'll be able to see, okay, I need a reviewer who can do it. You can add it to a max of 6 reviewers, you can do it, and wait time. So all those things can be done. And here you'll be able to control the secrets. Whenever you're creating the secrets, it can be created at multiple stages, which I'll be covering. And you'll be able to review the deployments made to an environment. And yep, so these are all fully integrated with the checks API. Earlier, it used to be called the deployment API, now it is. And as I mentioned earlier, it also supports the matrix build for the gated deployments. We can use it. So GitHub secret store is nothing but the secrets that is available as part of it. It's a built-in secret where you'll be able to store all your secret variables and everything will be masked. Nothing will be available outside. And if you look at it, it is a environment. Sorry, they are encrypted, and the libsodium sealed box is the concept that is being used for storing the secrets and encrypting them. And you have the option, so whenever you are creating secrets, you have the option to use them directly within your workflow, and they'll be redacted in the workflow logs as I mentioned earlier. So even if you want to print, it can't be. And it has the API support. So when I say API support, you have the option to create, update, and delete secrets. But remember, you can't read the value of the secret that is being uh, stored using the API. And the secrets can be created at your organization level, repository level, and the environment secrets also. At these three stages, you'll be able to create. If you look at the right side, the screenshot of it, three secrets I have just created. So one is at the environment level, which is the test environment I have created and I have kept it inside. And the repository secret, which will be used local only for the repository. And at the organization level also, I can create it, which can be used by all the repositories under it. And just taking a little bit deeper on the type of secrets. In the earlier slide, as I mentioned, you have three types. So if you look at the hierarchy of it, the environments and repository and the organization needs. So once you have it at the organization level, all the repositories or workflows under the repositories of it will be able to use. However, uh, it can be managed at a org level, it can be scoped, but what it can happen is, say, if you're using the same, the repository secret, if it's going to use the same name, then you'll be able to, it can override the org level secrets also. The hierarchy will be taken at the repository level. And the environment secrets are scoped to a single environment. When I say that, because there will be multiple environments being used, your testing, QA, all those things, and every environment will have its set of secrets, and it is local only to that environment, which can't be used in the other environments. Similar to the secrets, you also have the variables. So even at variable level, you have three type of stages. So one is at the environment, second is at the repository and organization. No difference between the secrets and variables. Secrets, as the name says, it is encrypted and it will be completely masked. Whereas the variable is kind of open, you will be able to see. Rather than storing it at the configuration file, you have the option to choose, store it here, and then use it whenever in your workflow, whenever needed. And we are using the secret. So because we have created the secrets and variables, and how do we use it within our workflow? It is going to be simple. So within your workflow, you'll be just mentioning dollar within the curly braces, just you'll be mentioning secrets dot, whatever be the name of your secret, that is what you're going to mention, and automatically the value will be fetched at the runtime from the secret store, and it will be assigned to the variable that you are trying to use. Similar way, you'll be using it for the variables also. You'll be, instead of a secrets dot, you'll be using the variables dot. That is the only difference you'll be using it. And however, there are some limitations with respect to the variables. Say you'll be able to store up to 1,000 organization variables, and 500 at an organization level. Basically, you can store up to 1,000. And at a repository level, max of 500, and per environment, a max of 100 can be used. And the total combined size limit for organization and repository is 256 KB per workflow run, which is a huge one for any enterprise. So we have not seen any challenges with that. And yep, and the permission, because in the earlier slides, whenever you are looking at the token, because obviously we'll be using the GitHub token that is being used. So the default permission can be set at a org level. So when we go over the policies, I'll be touching on that. And if you look at the permission, these are all, whenever I'm using a GitHub token, so these are all the default ones that gets assigned to it unless we do it. So which will be covering. And I know I'm running fast because we are just left with 20 minutes. I'm sorry about it. Yeah, demo, just give me a minute. So what we are going to do is, here we are going to have see a demo of it. So what will happen is the moment you get inside the repository, get into the settings of it, and you have something called as the environment. In the interest of time, what I have done is already have created the environment for us. In case you are interested in creating a new environment, just give a name to it, say, Arun. The moment you click on it, obviously it is going to ask. So these are all the things that you'll be able to configure as part of the environment, as we saw in the earlier slide. So in case you won't have reviewers for it, then you can add up to these many reviews. You can do it. Say only unless they review it and give the sign off, then you won't be able to progress further. And because there are projects and needs where they will say, okay, because I'm creating it, I don't want to have the self review. So this is where you'll be able to project and then take it out. And you have the wait timer. And so basically what it will do is it will be setting what is the time limit that you want to have before that, allowing the deployments to proceed. So it starts with the minutes. You can mention as you want. And say deployment branches and tags. So here at this place, you'll be able to restrict what are all the branches you want to do it and the tag. So either you can go with, say, if you want to go ahead with all the branches with nothing, then you can just go with that. Otherwise, you can just choose depending on the need. And within the environment secret, as I mentioned, the environment secrets and variables, this is the place where you can come and add all those which can be used specific to that environment. So that let me take a step back. So what I have done is I've just created this and I have done it. And similarly, so once you have created the environment, then you're good. Similarly, the secrets and variables. So you can just go here. You can create as many secrets as you want. If you look at the environment secrets, as part of the environments, we created one which is available here, which can be used. And this is at a repository level, which I can use. And this is something at an organization level, which I can use, saying that if I want all the repositories, because there can be secrets that is created at a project level or at a vertical level where all the repositories can use it. So that is where it will be. And similar case for the variables also. So if you look at it in the secret, the value will not be displayed. You won't be able to read the value. Only within the workflow at the runtime, the value assigned to it can be read. Whereas with the variable, it is going to be an open one. I can look at whatever value I have printed because it is not going to contain. Ideally, the variables are not supposed to have any sensitive data being stored in this. And yep, so what I will do is, okay, let me get inside the code part of it. Let's look at, already I have kept one, the workflow part of it. So the demo secrets environment. Okay. Let me get into the edit mode of it so that it looks bigger. No, it's the same. It's the same. I will just maximize the screen. So if you look at it, the template workflow that we have used, the same thing comes in. And I'm just limiting, if I look at it, I'm just limiting the GitHub token permission, what it can do. Basically, it can route the contents and the actions it will be able to read, and the deployments with respect to deployments, it has the right permission. And if you look at the environment, these are all the environment variables that I'm using within the workflow. So I'm setting two values, URL1 and URL2. I'm assigning a value towards it. And under the jobs, if you look at it, I'm just creating this is the job name and it is going to run on the Ubuntu latest. So when I say Ubuntu latest, it is going to be the GitHub hosted, a normal runner. And in case I can make further because it is going to be on the push and pull request of it. So I'm just checking, making a validation on what it is. Say if it is going to be a pull request, then what I'm going to do is, okay, under the name environment, I'm just going to set the environment URL value to this. And once it is done, then I'm going to check out. So this is how it is going to be executed. If you look at it, echo a secret, I have this, I can do it. So what we will do is, I'll just take a step back. I'll just edit the code. I'll just mention it saying that today is 21st November. I'm just going to commit the changes and just create a new branch. I'm saying patch 2, propose the changes. So that I have done it, I'll just create a pull request. The moment I get inside the actions, if you look at it, the background, it has started doing it on the pull request because that is what we saw. So the use environment 2 we are not using because the use environment 1 is the one we have given the condition. Say in case of a pull request, what is to be done? If you look at it, so in case of a pull request, I'm just going to do it in the test environment of URL1, which is nothing but github.com. I'm going to take it. So if you look at it, the user environment 1 is ready. If you look at the summary, so if you look at it, so it has assigned a value and it has printed that also. So this is how you'll be using the environments against it, and you can take it forward. And anything else I want to cover? Yep, I think we are good. So this is the part where we see and managing workflows and actions. Let's get inside this. So these are all the action policies that you'll be setting at any point of time. So what I will do is I'll just create one. Just give me a minute. Rather than going through the slide of it, I'll just go ahead with the demo immediate so that it will be easy for us. I just left with 15 minutes of time. So if you look at it, let me open it. So this is the part where we are getting into the picture. So you'll be able to see all those things. So this is, I have got inside. So So this is the part where I have got inside the organization profile and specific to actions, what are all the things I can configure. So policies. So basically what are all the policies I want to use. It is whether I want to restrict or implement it for all the repositories or only for the selected, or I want to disable the actions. All these things can be handled here. And similarly, what are all the type of actions? So basically allow all actions and reusable workflows when I give it. So regardless of whether it is developed within or outside, it doesn't bother. I can pick up a outside one that is available in the market open source and I can use it. Whereas there will be certain enterprises where they say, we just want to use only the enterprise actions and reusable workflow. So we can, depending on the need, we can choose it. And similarly, the runners, you'll be able to choose whether you want to enable the runner for all the repositories or select it, or there are no runners to be used. That is where it is. Obviously, if you're going with actions, you need the runners, but just a disabled part of it. And as the name says, artifact and lock detection, because whenever the actions workflow is getting executed, there will be logs generated and it's just going to eat up the space. So you can here, you can set a policy. By default, it is a 90 days period retention that it will be saved for. In case if you have too many builds or action pipelines getting executed in a single day, which is going to eat up your space, just you can make it to reduce it to just 1 day. So that all those logs and artifacts, whatever that gets downloaded can be cleared, and forking the pull request workflows from outside collaborators and similarly with private repositories, all those. And this is the part what I was referring with respect to GitHub token. So by default, it will always be going with the read and write permission. In case you want to have the read repository contents of the package permission, you can use it and do. Now a new feature has been also been added. Whether you want to allow the GitHub Actions to create an approved pull request, also you can do it. So basically, with issue ops, you want to do it, you can do it. So this is the page or the organization setting where you'll be able to configure every part of the actions that you want to have or want the users, the organization users to follow. This is the place you'll be able to do it. So this is what we saw. And we have something called as a sharing. So because the one of the questions what we usually get is how do you share? Because there is an organization and too many repositories, teams are working under it, and we want to share the workflow, a common thing. How do you do it? Say there are two ways to do it. So one is the reusable workflow that you can refer, and or you can go ahead with the start action starter template in .github repository. So the .github repository is nothing but let me open that. So you can just create a simple .github repository. And remember, if you want to share it, because it is more of a starter template that you are defining, so it has to be declared public. Unless it is public, you won't be able to use it or make use of it whenever you are creating any actions workflow. So if you look at it, just look at the workflow templates of it. It need not be presented within your uh, .github workflow and followed by the YAML. it will be outside it as part of your direct repository. So this is the test template that I have created. So which a simple event saying that whenever there is a push branch, a push happens on any of the branch, the default branch, then obviously it will get triggered. And the job will be executing on the Ubuntu runner, which is the GitHub hosted runner. And followed by just I have given a step saying that this is the workflow template. Because I have given it something like this, what can happen is the moment I get inside, say the workflow template, say let me get inside the secrets demo offer and just opening it. I'll get into the actions. When I click on the new workflow, you'll be able to see saying that the demo workflow template, whatever I have created and declared as public, it will be available. So this is one way. So the moment you click on it, it is going to open up, copy the same thing, whatever you saw. You can make the changes if you want. Otherwise, just use it as it is so that you can just, it will become part of your repository and you can start using it. So this is one. And then we have the reusable workflow. When I say reusable workflow, there will be some limitations. So maximum 4 level of workflow can be used. So one can call 4 levels. It can be able to call. Beyond that, you can do. And maximum 20, number of 20 workflows can be called within a single workflow file. So this limit, when I say 20, it also includes any trees of the nested workflows, reusable workflows that may be called starting from your top level caller workflow. And if you want to reuse the variables in the multiple workflows, then you have to set it at the organization level or a repository or environment level. So I'm referencing them using the variable context. And reusable workflows will be called directly within the job and not from within a job step. So basically, you can't use the GitHub environment to pass values to job steps in the caller workflow. This is how it is. Maybe I'll just share the documentation with this so that will be helpful on the reusable workflow. Yep, given it. And sharing the private action, as we saw earlier, unless they are declared public, you won't be able to do that because there will be certain actions what you want to do, or to say reuse your custom private actions, right? So there are two workarounds that you can use. So one is to make use of the GitHub container registry, use the GitHub packages and the container registry using the Docker execution so that you can just push it and make it as part of your Docker, and then they can reference it within their workflow. That is one way to do it. Another one, the second approach will be the GitHub app. So basically, you can start using the GitHub app to clone the actions. So it can be on the different repositories or on the actions monorepo or separate organization you can use. So that is where the different ways to share a private action. And caching is one of the concepts that has come in. So because there will be cases, because the runners are going to be ephemeral, and say for example you want to, you're installing certain software or tools which you don't want to get reset because it is going to take time. So that is where the caching as part of the action will come in handy. So basically it will be temporarily saving the file between your workflow runs that can be used later. And there is a 10 GB of max cache size per repository, and there will be 7 days of retention. So these two are the limitations that we have with respect to caching. And just to mention, don't cache any of the sensitive data because the data is going in and out, and using your visualization, you'll be able to see anything on that. So better not to use it. And in case you want to use any of the sensitive data, go with the GitHub secrets or use your own data vault that can be referenced. And the best practices and actions in an organization. So as I mentioned, use the GitHub token whenever possible. And as a second option, make use of the GitHub apps. And whenever you're creating any PAT token, basically the personal access token of GitHub, don't give all the permissions, restrict it. So depending on the need on the job or whatever the PAT is used for, only give that permission, and also scope the number of days, keep it limited, don't give unlimited, because anything it goes out, then it can backfire. That is where it is. And whenever you're using any actions from the marketplace, run only the trusted actions. And in case it is not, say, say for example, you want to use an unauthorized or a non-tech actions, then ensure that you run your own set of security tools on it, ensuring this proper and then use. And protecting your secrets with environments. So whatever secrets, say it can be your keys or anything you want to use it, protect your secrets. And For reusability purpose, go with the starter workflows. And last but not least, not just for the CI/CD, but also you can use actions for the ops. So when I say a star, it can be anything. It's a DevOps or a issue ops or anything depending on the need, because the use cases for actions is unlimited. So just we have to use however we want. And I think we are on top of time. Rashmita, do we have time to do it, or should we go ahead with the Q&A, the last five, or do we have time?
Sure, we still have time. Go ahead.
Okay, perfect. So what we will do is, I'll just walk you through this, the demo workflow, whatever we saw. Yeah, know the files. So this is what we already saw. So we are good with this demo workflow template. We saw that, right? So let me skip this part of the demo. Let me get into the building actions. So writing your own actions, there are three type of actions that are available. So one is the native JavaScript. So whatever you are going to write in the JavaScript or TypeScript, it will get executed on the native runner. And if it is going to be a different language, which is not being supported directly, then you can just package them in a Docker and then use it accordingly. And the last is nothing but the composite actions. So basically, composite actions are nothing but you'll be able to run the shell scripts directly within your action.yaml. So as part of your steps. And action.yaml file, so you'll be able to define. So these are all the things, metadata that are to be defined within your action file or the inputs. So what are all the inputs that are to be taken, and similarly, what are all the outputs that will get generated, inputs and output parameters basically. And what does the type of action do? In this case, say for example, Docker. So if you look at using the Docker and the Docker file, so what is the purpose of it? And as I mentioned, so it need not be within your .GitHub workflow path of it. It can be totally outside the path, the different path in the repository. And basically, it will be sitting along with the rest of the code of the action. It can be in the same repository as the workflow, but it can be kept in a different repository altogether also. And using the GitHub API, so we have the REST APIs that are available as well as the GraphQL API that are available. So the REST API, if you look at it, the libraries are available for most of the languages. You can use the AutoKit and then start doing it. And similarly, GraphQL is on the version 4, which is the future of GitHub API. The difference, if you look at it, the REST API is going to give the complete dump of the data, which you may not need also. So that is where the GraphQL can come in handy. You'll be able to narrow down only the set of values that you require rather than getting the full data set. And what are all the best practices in case you are writing your actions? So always have a proper design, so that always keep in mind whenever you are creating your own action, saying that it has to be a reusable one. So keeping in mind the design for reusability whenever you're doing, and always have the proper test cases being written so that you can test it, and have proper versioning of it, because there will be always whenever you are creating actions, it's not just going to be you can just, whether you want to have it as an open source where people can collaborate, or within your enterprise where you want other team members to come and do it, it is a good habit to have the versioning part, so that anyone who looks at the readme file, when they go through the repo, they'll be in a position to understand what are the changes that have happened in the different versions and what is the evolution of this particular version of it. And have the proper documentation. And as I mentioned, the proper metadata should be there. What are the set of input, output, what is the thing, all those. And publish your actions. Last but not least, in case you feel you are proud of your custom actions, whatever you have written, you think it will benefit others, just ensure that go and have it to your marketplace so that others can start also using it. If you look at it, this is a simple example on how a proper GitHub action, say, for example, whatever we cover as part of the best practices, how it can happen. So this is an example of the repository, what we usually share. If you look at it, maybe I can just copy this. I'm sorry. Just a minute. So if you look at it, as I mentioned, the about part, if you look at the README file of it, it will be clearly mentioning what all the things it has, the integration has been passed. Similarly, the CA, the integration, and the license, what type of license it is, everything will be mentioned. And if you look at the releases, it will be having all the versions, how many releases, close to 42 releases have happened. And the latest version got released just 4 days ago. So if you keep scrolling to it, so these are all the things, say what are the arguments, right? So it basically gives you what are all the changes that have been, how to use it. And as I mentioned, these are all the versioning that are being used. So under every version, you'll be mentioning, say for example, the version 7 of it, instead of the Note 16, it started making use of the Note 20. Similarly, the version 6, what is the change from the earlier version? All those things can be given here, so that anyone who comes here as a first time or whenever they want to reference the repository, it will be easy for them to understand. And in case you want to be part of the development, so there, if you look at it, always you can just get inside this and see how the development works, right? So all those things, everything. So the complete set of instructions can be given, which will be helpful for others whenever they are getting into it. So it is one of the best practices that you should follow whenever you're writing the actions. And moving on to the runners, so you have to, I don't want to keep repeating it because already we have seen it. So what I will do is, maybe I'll just jump into the part where how you do it, right? So what we can do is, I'll just open up a new tab. I'll just come here. Give me a minute. Say for example, this is my organization, I want to create a runner, right? So that's where it is. I get inside the runners of it. So here I'll be able to do. So this is the place, as I mentioned, in case you are going with a GitHub hosted runner, whether it's a large runner or you're going with a self-hosted runner, this is the place where you will come and give it. The self-hosted runner, let me start with that. So basically you will be having your own infrastructure and you're going to have it. So depending on the environment that you have, whether it is a Mac or a Linux or Windows, you can just use, choose whatever be the OS of it. Say in my case, I will say Linux in this case, or a Mac, and I can also use the architecture, whether it is a x64 or a ARM64, I can use depending on the infra what you have. And you'll be simply following, you just need to simply follow the instructions, whatever is being given. Basically, it will be downloading the tar file of it and it will be execute, and it is going to set up the complete runner. Within in a span of 2 to 3 minutes, the runner will be up and running and you'll be able to connect to it. So as if you look at it, once it is up and running, then within your YAML file, you have to just mention saying that it is a self-hosted runner, and you can just add the labels. Once, I don't have it handy right now, but once you have the runners ready, self-hosted, then you'll be in a position to create the labels so that you'll be able to pick the appropriate runner within your workflow. And similarly, whenever you're going with a new GitHub hosted runner, which is nothing but a large runner, yep. So basically, this is the place you'll be landing on. So right as of now, you have the Ubuntu and the Windows server that are available. And here you can look at the various versions of Ubuntu that you can choose depending on your need. And similarly, what is the runner size? So it will be a combination of your CPU, RAM, and the SSD. So based on your need, you can just go up to a max of 64 core and 256 with a 2 terabyte SSD. And here you have the option to auto scale, right? Because if you look at this is a new concept that were available for the large runners. So here in this place, you'll be able to, you want to have multiple runners. How do you auto scale depending on your need? You want to increase or decrease. So this is the place where you can mention it. And there is something called as a runner group where you can just create a group. Okay, let me get inside. So once you have the actions and get inside the runner groups, default, otherwise you can just go with this. So I have everything, that is why I can go with the runner groups, and then I can do it, I can get it added otherwise, so it will be able to do. So if you look at it, the default one is available. In case I'm looking for a new runner group, I can just give a group name, say, and I can choose what all the repositories which can have the access to this runner group. I can choose it in case I want. And allow public repository is something that you can choose, but Usually, we don't recommend that too if it is going to be a self-hosted runner because we never know what is the security threat involved as part of the code that is available as part of the public repository. So better to restrict it to have only the internal and private repositories for part of your runners. And similarly, the workflow access you can choose whether you want to have all the workflows or have only the selected workflows. You'll be able to choose and create a group accordingly. So this is the place where you'll be able to do this. So the moment I click on it, yeah, it has come in. And once I create the group, I can just keep adding the runners as I want. I'll be able to do it. I can get inside, say this is the new runner. I can add as much as I want, whether it's a GitHub hosted large runner or it is going to be a self-hosted runner, I can do that. So this is the place. And yep, adding the same self-hosted whatever we saw in the demo. I'm just skipping the slides in the interest of time, and I'm getting into directly into the demo. And as I mentioned, the self-hosted runner security, malicious public repositories, basically, we suggest not to use this because there can be malicious programs running on the mission and sandbox, all those things. So that is where always get a self-hosted runner. Another thing recommend we go with only the private and the internal repositories. And scaling runners. So GitHub hosted runner, as I showed you, you have the auto scaling supported as part of your GitHub hosted large runners. And there is something called as the actions controller ARC, basically for say scaling the self-hosted runners. Because since a certain time, because it was introduced very recently, say within a quarter, and before that we used to have an open source solution. Now it has become part of it. So when I say ARC, it's nothing but a Kubernetes operator that will be orchestrating and scaling all your self-hosted runners for the GitHub Actions. It is available for your on-prem 3.9 onwards. If you're on the earlier versions of it, it is not available, but it's available for all the cloud version of it. And this is the respect to it, and this is what we saw. And CD workflow. Yeah, the last another two more or three more slides. That's it. So basically, as I said, if you look at it, we have the matrix version, the matrix build, what I covered in the initial introduction phase. So if you want to try out your the workflow execution, say the build part of it across multiple combination of environments. Say in this case, I just want to try it out on my node version of 10.x and 12.x. So the moment I declare the matrix and I use it as part of my node version is equal to say name users and action set up the node using the matrix, then it will be setting up this application using the version of 10.x and 12.x. You'll be testing and coming out of it. So usually it will be uh, helpful for as part of your test cases when you want to do it, and all the artifacts will be uploaded separately. And linting, as part of the linting, you can just use as part of your CA run. Say you want to have a linting which has to be run on top of your code, then you can use it. You have the support, you can just go with the super linter that is available as part of GitHub, and it supports around close to 45 different languages. And just like how we saw the checkout, similarly the super linter just with a single command uses, you'll be able to use it within your workflow file. And basic CD workflow. So it is also the starter workflow is available for most of the cloud providers, whether it is Azure or GCP or AWS, it is available. You can just get it. If you look at it, so we have got it. So this is basically, it will be running on the Ubuntu latest. It is going to download the artifact, keep everything ready, even including the Docker, it is able to do. And the second part of the job is nothing but the build, deploying into the Azure environment. So we are here also will be using the Ubuntu latest. So depending on the need, you can change. In case it is a self-hosted, then you'll be using it accordingly. So using the deployment part of it, so the web apps container, say I'm interested in deploying a web app container into Azure. So this is how, because if you look at the marketplace from Azure, because from Azure, we have got a couple of apps that can be used, you can use and take it forward. Yep, I think we are good. Any Q&A, happy to answer it. Let me look at any questions. Yep. Okay. There are no questions. Yep. Thanks for everyone's time, and thanks Rashmita for setting it up.
Thank you, Arun. I think that, uh, okay, I see. Okay, the answers
Yeah,
are
I think
already
I see
been
Abhi and
given.
Dhruv have answered it. That's where it is.
Yeah, yeah, sure. Okay, I think we are good for today. Thank you, Arun, for hosting an amazing session, and thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming session. Feel free to use the Learn module link shared in the chat section. This will give you access to additional resources to take your learning further. Thank you all once again and enjoy the rest of your day.
Thanks, everyone. Bye bye.